All right, here we go. Here's your homework assignment for chapter 18. And let's just take a look at problem one. All right. Well, student access, uh, you're not allowed on Blackboard yet. As of this recording, I think you get on next week. I'm going to make it available as soon as I can for you all, especially before I get out of town. I don't want to hear that, but anyway. So it's not the homework's not due till June 12th, and then your homework number two is not due until June 13th. So we'll be back together. That's like that gives you like that Wednesday and Thursday night of our second week to get it done. But remember, you're going to have an exam over 18, 19, and probably the start of 20. All right, when we first get back, it's going to be, but it won't be bad. Trust me. And plus you get a drop in exam. All right, that's what I've changed over the previous semester. Is I'm not replacing your top score. I'm just dropping a score. That makes it more fair. That makes it much easier for me to compute, and that still allows you for a bad day. All right, and it's just easier for all of us all the way around. All right. So anyway, all right. So here we go. So let's look at this. Here it is. Yes, it'll be just like we had before. If you miss the due date, you lose 10% for the first 4 days. It's not late, so and then it's 50% after that. So you'll always get some credit for your homework. All right, so let's just go ahead and look at problem one. It says iron atoms have been detected in the sun's atmosphere, some with many of their electrons stripped away. What is the net charge in coulombs of an iron atom with 26 protons and 14 electrons? 26 protons and 14 electrons. Be sure to add positive. So first of all, what's this charge going to be? What is there more of? There's more protons. In other words, it's got eight extra of protons. So we just need to find the charge. So we need to find, so what's the charge? That comes out to be a pretty easy problem, actually. So problem number one. So this is page 3, and so this would be homework number 1. That turns out to be not that bad of a problem, because if you got 26 protons and 26 and 14 electrons, okay, the total charge on this, Q on this, would be 26 times positive 1.6 times 10 to the negative 19. That's the charge of the protons. The charge of the electrons is going to be 14 times negative 1.6 times 10 to the negative 19 coulombs. So that negative charge will come out here. And so you wind up with, I can factor out the 1.6 times 10 to the negative 19 and get 26 minus 14, right? And so that'll leave me with 8 times 1.6 times 10 to the negative 19. Now, let's make sure we figure, so when I do that calculation, which is fairly straightforward, I'll go, okay, so I've got 8 times 1.6 second e to the negative 19, and I've got 1.28 times 10 to the negative 18 is my net charge. It's not much of a charge, 1.28 times e. Now let's see how we put that in. Let's make sure the number will be positive. 1.28 capital E negative 18. Oh, I've got to change that tolerance. That tolerance is awful. Units, coulombs. Uh-oh. That's got to be right. Oh, it's 12. Oh, you all are sitting there, wait a minute. When did 26 minus 14 become 12? When a moron was teaching your class, that's when. Okay, so let me try that again. Let's do second. Now watch this. Watch how I fix this. I'll go to second entry, because I was like, well, how second, and let's change this to a 12. Now 1.9. How about them apples? 1.92. Let's try that again. Positive. At least I got the units right. Yes, I haven't changed. E to the negative 18. Let's submit that answer. There we go. Notice capital E for the exponential. So most of you already knew that. Let's see what the next one looks like before I log us out of here on this one. Oh, this is a great problem. All right. I want to show you something, and then we'll go back to this problem. All right. So let's go ahead and take a look at this. Let's say, and as a matter of fact, let's go to this. Oh, we already talked about this. Now, so it's positive. All right, let's take a look at this problem. Okay, 3 identical conducting rods. All right, so we're still talking about charging and moving charges around. We haven't talked about forces yet. All right, so I put a negative, and it actually touches it. So the negative charge flows through here. All right, so what happens? The negative charges on this guy go, whoa, they run over here. And the negative charge on this until it all balances out. Finally, the rod is, what is the sign of the final charge of each of the 3 spheres? Well, they're all going to have the same negative charge. So it'll be negative, negative, negative. It should be E, and it is. Now, this is a cool problem. Look what happens here. Let's do this problem. All right. This is question 6 on your little take-home quiz. All right. Consider the conducting spheres labeled A, B, and C. All right. Notice these 2 guys have 0 net charge. Now they have charges in there because they're made up of atoms, and atoms have positive and negative charges. But they're all neutralized. If I have a lump of carbon, it's got a negative charge because it's got what is it? I got to get me a periodic table and just look at it. Number of protons, number of neutrons, and then the number of electrons matches the number of protons, and so therefore it's neutrally charged. But now look. This one has a Q of 1. Now, in the next step, what we do is we hook up C to A, which is hooked up to B. So, and then we and then we move on, and then then A to C is hooked up, and then we unhook it. What are all 3 of? So here's what's going on in this one. Let me show you. 0, 0, 1 coulomb, which is a heck of a lot of charge, or 1 Q. We don't know what the Q is, but it's 1 Q. All right. So now, put it here. Ooh, if I just put it there and stop, if that and then stop, what's going to happen is this will be at 1/2 Q, and this will be at 1/2 Q. But now I'm going to hook it up over here to this 0. All right, and they're all going to be the same. Now we're not going to get 1/4, 1/2, 1/4, 1/4. They're all going to be the same. It's the same as if I did this and put them all together. This is 1 Q. This is 0 and 0. Hold them there. Then here's what happens. They all get the same amount of charge. In other words, the electrons run towards this positive Q, all right, and start to knock it out and start to lower it, and then until they're all the same. And then when I separate them, I've got Q over 3, Q over 3, and Q over 3. Because what happens is 1/3 of the charge is here, 1/3 is here, and 1/3 eventually is on this one, evenly distributed. Okay? So you take the net charge, however many balls you have, you take the net charge and divide it by the number of orbs. That's the best way I can describe it. So we'll go on to, so I'll hold you in suspense. We'll go on to the